last section of chapter 7 is about more proportional parts in similar triangles. So yesterday we talked about adding in parallel lines or mid-segments and those being proportional. Today we're just going to add in even more segments. So in similar triangles, corresponding altitudes, medians, angle bisectors, anything that you add on to those triangles will also be proportional with respect to the triangles they are a part of. So if you look at this example that I have on the left, triangle KLM is similar to triangle XZY because they have angle-angle similarity. Then if I were to add in the altitude on each triangle, so in this case, PM and YQ are both altitudes. Those altitudes are going to be similar with respect to the triangles that they are a part of. So we're just going to have to set up some proportions. So, and I said this, but maybe I'll write it down. I know triangle KLM is similar to triangle XZY. So it looks like KM is going to correspond to YX. So maybe I'll make one of my fractions 20 is to 15 as, and then I'll relate the two altitudes. So PM 16 is to YQ. Now we've got our fractions, so we can cross multiply. 15 times 16 is going to be 240 equal to 20x. Divide each side by 20. X should be 12. Then we've got another similar example. So I know triangle TSR is similar to triangle WVU because they have that angle-angle similarity shortcut. I almost are congruent there. All right, and it looks like that line that I drew in on each one, in this case it's PT and QW, are both angle bisectors. Or actually they're medians, not angle bisectors, because they go to the midpoint of the opposite side. So since these two triangles are similar, their medians are also going to be similar. So it looks like we're going to relate SP, which is X, to UQ, which is 3. So I'll say X is to 3 as the two medians relate. So 13.5 is to 9. And if you wanted to, you could have related the whole side. You could have doubled it. So we would say SR, which would be 2x, and UV, which would be 6. But I don't think we necessarily have to, just because these triangles are similar, so all their corresponding parts are going to be proportional. You should get the same answer if you had doubled it to be 2x over 6 versus just x over 3. All right, now we're going to cross multiply. 3 times 13.5 is 40.5. X times 9 is 9x. Divide each side by 9. X should be 4.5. All right, and then the last thing that we are doing in this chapter is the triangle angle bisector theorem. This says an angle bisector in a triangle will separate the opposite side into two segments that are proportional to the lengths of the other two sides. So in this case, in this triangle, JM looks like my angle bisector. So we know that KM, so this portion where the angle bisector meets to one corner will relate to LM, so what's going on the other side, as JK relates to JL. So just another proportional relationship that exists inside triangles like we did with parallel lines yesterday. So in this case, I want to find the value of x. I can see that that line is an angle bisector. So I know that x is going to relate to 4 the same way that 13 relates to 6. So let's set up a proportion and figure out what that relationship is. X is to 4 as 13 is to 6. I'll need to cross multiply to find x. 13 times 4 will be 52. X times 6 would just be 6x. 52 divided by 6. It's going to be like 8 2/3.